reading through. Historically, more juniors than seniors. Sorry, historically, 10% more juniors than seniors take the ACT during a given school year. Wanting to see if this has changed because of the pandemic, a sample of 500 juniors showed that 290 of them had taken the ACT during the previous school year. Similarly, 195 of the 500 seniors surveyed had also taken the ACT during the previous school year. Does this data provide enough support to claim that the difference in the proportion of juniors and seniors taking the ACT has grown? How is this different than the examples we've done so far this morning and yesterday? So we're assuming that there is already a difference between the two groups, right? How much difference though, Connor? 10% more juniors than seniors take the ACT in a given school year. The difference between the two proportions is not necessarily zero. In this case, the difference between the two groups is 10%. I want to see if it has grown, if it's which direction. Bigger or smaller than 10%? Bigger, greater. Has the difference expanded because of the pandemic? Have I caused more juniors to take the ACT than seniors? Maybe there's less seniors because they're going into a gap year. They're not going right away into college. I don't know. That's just kind of how I thought of this as I saw Ms. Hopkins' email yesterday about getting signed up for the ACT. So which group do you want to call what? Let's do group 1 first. What do you think? Juniors, okay? So for my sample of 500 juniors, we know that P hat 1 would be the part that took the ACT, so 290 of 500. Q hat 1 would be those that did not, so 290 did, the 210 did not. I'd do the same from a senior group. The seniors, 195 of 500. I have another sample of size 500. How many took the ACT? 195. So P hat for group 2 is 195 of 500. I can't do that math in my head. What's Q hat 2?
305.
Yep, 305. Yeah, that's right. 195 seniors took it. That leaves the other 305 that did not take the ACT. Let's run through all the different parts of the hypothesis testing. Some conditions. Can I assume that this was a random sample of 1,000 upperclassmen? I hope so. Is 1,000 upperclassmen less than 10% of all students that take the ACT?
Yes.
I hope more than 10,000 people take the ACT in a given. Less than 10% of those that take the ACT test. Check the counts. I have to have at least 10 successes and failures per group. All right, that looks good. And that looks good. 290 junior, 195 senior, took it. 210 junior, 305 senior, didn't take it. At least 10 successes and failures qualified as either taking or not taking an ACT. Here's where it's going to get a little bit different. And once again, why is this different than the example we've covered so far on hypothesis testing for the difference in proportions? There's a difference already. I'm not assuming that the proportions are the same between the two groups. How much difference is there to start? Okay, so the difference. I take P hat 1, sorry, if I take P1 minus P2, I take the difference between juniors and seniors taking the ACT, based off what we've been given, what should that be equal to start with? And we're testing to see if it has grown. I take a sample, and what am I trying to prove for my alternative? Be more seniors taking a gap year. They're not as interested in going to college. College experience isn't worth it during a pandemic. Which tail? at the 5% significance level. So what's the z-score that cuts off the 95th percentile? 645, is that what we're seeing here, Norm? Yeah, 164. Part 4. Let me get the formula written back up on the board. The other side. Look at what we know. P hat 1 minus P hat 2. Looks like I've got 290 of 5 minus 195 of 5 minus 1. What do we know about the difference in P1 and P2? What do we assumed about it to start with? What difference, though, Connor? So I'm going to subtract off what P1 minus P2 is equal to, which is? Is this difference from our sample more than the 10% we're assuming to start with? That's what our hypothesis test will hopefully show. A statistically significant difference than what it's already supposed to be. 290 of 5. 210 of 5. It's 195 of 5. It's 305 of 5. All right, that looks like a mess, but let's try and see if we can get it typed into the calculator correctly. Okay, from our sample, at the difference on the screen, look at that. From my sample, it showed that 290 of 500 juniors and 195 of 500 seniors took the ACT. So when I took the difference, what does that difference mean in context? The difference is 19%. What does that mean? What percent more juniors than seniors took the ACT? 19%. What should it have been? Like in a normal year? 10%. Is the difference between the assumed difference between the two proportions, 10%, compared to my sample, 19%. Is that difference statistically significant? Hypothesis test will tell us that. All right, so let's see here. I copy that. And then type in the rest. We've got 290 of 500 times 210 of 500. 500. Plus the combined error from the second sample, the seniors, 195 of 5 times, what was that, 305? There's my z-score, about 2.9. What do you say, man? Here's the two z-scores. Reject or fail to reject? Reject. 2.9 is more in the tail. It's more extreme. It's less likely than what defines our rejection rate. Yes. Let's also find the same p-value. I need a p-value for a z-score at least as extreme as 2.9. Which tail do you look up? Hang on a second, guys. I still got about 5 minutes left. Right tail. So 2.9 on your Z table. Remember, I want the right tail. 2.9 looks like 0.9981. But I want the part to the right. So how do I adjust this number? What's that? Second check. Do I have to double it? Like I did yesterday? Because it's what? It's got a gyro. 110.
It's got the key, bro. Chiropractic stuff is
So if the difference between juniors and seniors taking the ACT is actually 10%, I'd find the 1,000 students in my sample with their difference between two proportions about 0.18% of the time. Is this statistically significant? Is 0.18% within my 5% error? Yeah, so what's our decision? Reject again, just like Maya said by using the critical score approach. By comparing the z-scores, we said reject. By comparing the p-values, we also said reject. What does that mean? Put it in context. Practice writing your conclusion. Put this in context. Do we have the evidence or lack the evidence? We have the evidence to make what claim? The actual difference between the proportion of juniors and seniors taking the ACT is greater than, which is, there we go. Let's be specific here. Yes. We have the evidence to say that the actual difference in the proportion of juniors and seniors taking the ACT is greater than what? 10%. Have evidence to show difference in the actual proportion of juniors and seniors taking the ACT is more than 10%. In fact, it's probably significantly more than 10%. Our sample showed 19%.
this year's.
Yeah, I think the pandemic probably had an impact on the proportion of juniors and seniors who are thinking about going to college right after graduation.
Also the fact that
That's also true too, right? Yeah,
it's like, oh,
that's also true too.
you don't want to